Alright, here we go. We're going to have a little video on how to use our calculator to work with some matrices. So what you're going to need to do right now is pause this video and grab your calculator. So this is what we're going to do. We are going to start by taking determinants with a 3x3 matrix. Why? Well, so you can use matrices to solve a 3-variable system. So how to use our calculator to do this? You can do it by hand, but I don't think you'd really want to know how to do it by hand when you see how much is involved. So let's do it. To use our calculator to enter a matrix, the first thing you need to do is be familiar with the matrix menu. It is second, and then this button right underneath math, the x to the -1. Okay, so then that takes you to 3 things. You have names. You only use that when you want to use the matrix. Then we have math. That's going to be some mathematical calculations. As you see, number 1 is determinant. And then finally, edit. That's where you go to enter your information for the matrix. So for this one, we are going to edit. And I always like to edit matrix A and B. That's just who I am. But you obviously have a whole bunch of different options. So you click enter on matrix A in the edit menu. First thing you have to do is tell the size. So this is a 3x3 matrix. So you just hit 3, enter, 3. And then when you press enter again, it'll scale it to a 3x3 matrix. Now you just need to enter in all the information. So it'll go left to right. So we have 2, 4, 6. So you just have 2, enter, 4, enter, 6, enter, -7, enter, 3, enter, 8, enter, 12, enter, 0, enter, and -2. And then you click enter one last time. You look at it really quick to make sure you like it. And if you do, you press second and quit out. So now what we're going to do is we're going to take the determinant. So to take the determinant of that matrix that you just entered, you have to go back to the matrix menu by clicking second matrix, slide over to math, and determinant is number 1. So you click number 1 or press enter when it's highlighted. And now you need to go back and get that matrix. So remember what I said, if you are going to use a matrix, you go to second matrix and you go to names. We are going to use matrix A, which is a 3x3. Close your parentheses. Click enter, and it took the determinant of that matrix for you. So the determinant of that matrix is 100. And when you enter it in the calculator, remember it needs to look like this. And then you just press enter and it does all the work for you. Okay, now there's different things that we can do with the determinant of a 3x3 matrix. Back in geometry, you guys took you found areas of triangles. Well, if you had the 3 vertices of a triangle, you can use your graphing calculator to find the area for you if you were given 3 vertices. How you do that? It's just plus or minus 1/2 of the determinant of those 3, but you just use a filler of 1s in the last column. So this would be coordinate 1, 2, 6, 2, and 4, 0. And area is always positive. That's why the plus or minus is there. Basically, just remember, your answer always has to be positive. So what you need to do again is you just go back and you're going to enter that into a matrix. So you're going to go to second matrix, slide over to edit. I still like matrix 1. So you still have the 3x3, which you need. And now you just go change everything. Alright, see how that's magically entered into my calculator? So what we're going to do now is, again, you quit, and you could tell your calculator to take 1/2. Don't worry about the plus or minus, okay, because you just use your common sense for that. So we have 0.5, second matrix, slide over to math. Number 1 is determinant. Second matrix, number 1 is matrix A. Close your parentheses. And then we just press enter, and it's going to tell us that the answer is -5. We use our common sense and say that the area is 5 units squared. We do not have negative areas. That would just be kind of weird. Okay, so that's that. now moving on. Cramer's rule can be used to solve systems with 3 variables. Of course, it is going to be your job to set it all up and then use your calculator over and over and over again. This is pretty time consuming. It's much quicker to do elimination like we learned the other day. But if you would like to use your calculator to do so, you do it. So I will help you set it up, and then the calculator part will be on you. So we have 4 matrices we need to create now. We have our denominator still, and then we're going to have our numerator for x, our numerator for y, and our numerator for z. Now we do it the exact same way. So it might help you to put in some placeholders here if you feel the need, like a 0z and we have a 0x. So our determinant for our denominator is going to be 1, 4, 0, 3, 8, 3, 0, 2, 1. And then you would use your calculator to find the determinant of that. And then we're going to do the exact same thing like we did in a 2 by 2. We are looking for x, so we are going to replace the x column with our 16, 92, and 18. Leave our y, 4, 8, 2, and leave our z, 0, 3, 1. And you know what I'm about to say for y. You leave your x, 1, 3, 0. You leave your z, 0, 3, 1. We replace the y with our 16, 92, and 18. Finally, z, we leave our x, 1, 3, 0. Leave our y, 4, 8, 2. Replace the z, 16, 92, 18. And you now have all 4 matrices set up. And now you would just have to use your calculator over and over and over again to find the determinant. So that job I will leave to you. If you do it correctly, you will get a negative 10, negative 120, negative 10, and a negative 160. The calculator will do all of that for you. So your answer is going to be very similar. It's just going to be nx over d, comma ny over d, comma nz over d. And then you will end up with 12, 1, 16. Now, you may not believe this, but in the next video, I'm going to show you how to do this in a much quicker way than solving by hand or by determinants combined. But until then, this is your next option with a calculator. Okay? So we're going to use inverse matrices eventually to solve systems, and it's really, really quick. So before we get there, you have to understand kind of what some identity matrices are. Identity, that's kind of like multiplying by 1, and it's diagonal 1s and everything else is 0, starting from top left to bottom right. That's the identity matrix known as matrix I. Whenever we talk about matrix I, that is the identity matrix. Now, inverse matrices, it's kind of like the inverse of multiplying 2 is multiplying by 1/2, and it brings you to 1. When it comes to matrices, when you multiply inverse matrices, they will multiply to I, the inverse matrix. So, and the thing is, it's got to be true for both. A times B is equal to I, and B times A is equal to I. So we don't need to get into how we do all of that by hand because we have our fancy calculator. And I'm going to teach you how to use it like a fancy calculator and not just a little TI-30X push a couple buttons and get a couple answers type calculator. So how we find the inverse? We're going to take the inverse of this guy. Now, just to show you, we can go to second matrix, and instead, if I want, I can go edit B if I want to. I would just scroll down to B or press number 2. That way I have a 3 by 3 for A already set up if I want to use a 3 by 3 again. And I can just make matrix B my 2 by 2. So 2, enter, 2, enter. And we've got 2, 6, negative 2, negative 5. Okay, so we enter that into the matrix. That's supposed to be a -5. And in the calculator, this is what you need to do. You need to type matrix A. So to do that, we go to second quit, and we do second matrix number 1. I'm sorry. Second matrix number 2, because we're used B. And then you just click this x to the -1 button. This is your inverse button. So what you need your calculator to say is the inverse of B. Click enter, and it's going to give you this, and then all you have to do is from here you can press math, enter, enter, and it will change that into fractions for you. So the inverse of 2, 6, -2, -5 is -5 halves, -3, 1, 1. That is the inverse of this matrix. Okay? So how we do it, we would need to use some determinants. We would divide each thing by determinants. We switch a couple. We just make a couple negative, and then we have to multiply or distribute, or we can just use our fancy calculator. So to solve a matrix for a big matrix, this x right here is actually a matrix that we're going to solve. So to do this, we're going to call this guy matrix A, this guy matrix B, and we just use our calculator, and we say matrix A times, or the inverse of matrix A times matrix B. So what you're going to do is use your calculator. You need to enter 2 matrices. So we're going to go edit matrix 1, and we're going to call that a 2 by 2. And we're going to enter for -1, -3, 1. And then you're going to quit out. You're going to go back, and you're going to now edit matrix B and put that as our second matrix. So that's going to be 8, -5, -6, and 3. Quit. And now you just need to do second matrix A raised to the -1, second matrix B, click enter, and it solved it for you. So matrix X is equal to 2, -2, 0, -3. And that's how we use inverse matrices to solve to find another matrix. And that's a little hint of how we are going to be using matrices to solve a 3x3 system, even a 4x4 system, a system of any size, using inverse matrices. That's coming up next. So thank you for watching. Have a great day. We'll see you soon. LongoWTHS.